report. Okay, and then let's see, share screen. Share screen. Share. I need to find. Oh, yeah. Okay, so now let me see the first example. Oh, I needed to go back to admit. Let me see if I already got. Okay, that's taken care of. So today we're going to continue our discussion about generic. So yesterday we learned generic. I needed to do annotation. So generic. Why my touch pen kind of not working very well. So yesterday we learned the generics, the basic concept, okay, and we learned generic class. And we also said like the stack and the queue, we learned from collection library, both of them are generic class. And we also learned the generic method. And on generic method, we also learned like bounded generic method. And you can also, for generic class, it's the same thing. Whenever you declare the generic type, it can be bounded one, okay? So that's the major ideas from yesterday's. And regarding generic, each time when you want to use generic class, just make sure, like in main. So in the generally what we said in the driver program, okay, and you cannot do new generic, okay. So never do new T something. That's wrong, okay. So that's illegal. That's illegal. So in the driver, you always need to plug in with a specific type. So like what we learned is like stack. You can do integer, the st, and then you do new new stack. And over here is it. And we didn't plug in anything, is it? But that's going to be matched from whatever you defined on the left side. So it's going to be plugged in with integer. Hold on, I need to admit. Need to be plugged in with the specific type integer, okay? And but over here you can leave it empty, is it? And we call this type inference. The concept here, we call it type inference. Okay, and on the other hand, generic, I remember last class we also mentioned is Java. Just keep that also in mind, okay, because in your future, maybe when you go to job interview, sometimes they may ask that kind of question. So Java is a strongly typed language, okay, versus like Python or like JavaScript. They are not. Okay, but Java is strongly typed language. And regarding generic, so generics helps a lot with the strongly typed language, because whenever you want to use a variable, you still need to give the concrete type. So that's one of the nice thing for generic. So it's still aligned with strongly typed programming language concept. On the other hand, generic also relieve the burden to do casting, etc. So it kind of can relieve that burden. That's the generic kind of quick review. I have another thing I forgot. So whenever I recall that the other thing, I will bring it back. Okay, so that's general review about generic. So today, let's first take a look at this, a generic method. And yesterday, basically, we already learned generic method. Okay, so just another example, let's take a look. So this method called search. This method is the search method. Search method, and what we plugged in, we have two parameters. Okay, we have two parameters. So one is array list, and the other is just a regular item. And both of them are the generic type. Is it? And so this method itself is also a generic method. So over here, before the return type, we have that angle brackets and the T. Oh, now I recall what I need to mention. Yesterday, I may forgot to mention that term. Regarding with generic, a lot of time we call this a type argument or type parameter. So in this case, because this is a parameter, is it V as we call it a parameter. So the T over here, we have a name, we call it type parameter. And whenever you have some class like over here, we mention like that generic stack or generic queue. And then there is another term, you can see both of these two is, this you can also call it a parameterized, so parameterized stack. Okay, because it's kind of look like a parameter, etc. So you can also call it a parameterized, okay, stack. And for this queue, you see, oh, it's a parameterized queue. Okay, so basically it's generic, and the parameter over here we call it T. And when we do like the method regarding the parameter, in this case, it's we call it a type of parameter, is it? And later on, when we plug in, if I call like a search and something, is it in my example, and then I plug in, suppose str, is it? Then over here, we call it type argument. Type argument. Because generally speaking, we call this, when you call the method, whatever you plug in, you call it an argument. So that we call it a parameter argument. So just some term in case if you read some other article or other material, then that makes sense. Okay, so for this generic method, so it's a pretty simple method. It's just try to search something. But with a collection, basically it has function to do some similar search job like contains or the method, is it? So, but over here, just try to show us idea. So anyway, this is a generic method. It's regarding the array list generic collection, one of the generic collection data structure. And it's going to look through all of the items, and then use equals to check if you get the item. And if you find it, then you can return where it is. Otherwise, you just return -1. That means you cannot find it. And also over here, we use the equals, is it? And I remember previously, we also explained the equals method and the difference between. So just also keep in mind the difference of equals versus the equal sign. Okay, equal sign, normally you can use it with primitive or the deep copy. Okay, and the equals just check the contents. Okay, so the method itself is not too hard. And then let's take a look at the main part. So in the main part, then over here, we have two array lists. So we have this V1, okay? And the V1 is an integer array list, is it? So we create the new integer array list. And one more thing, just be careful. Like in main, like I said, you can never do new array list T. You cannot use generic type. You always need to plug in with a concrete type, okay? And then the second array list object is a character type, okay? So we initialize its object. And then the later part is just we add all of the items to the array list. So in this case, it's an integer, is it? And then we try to find if a certain item is within that array list, and using that search function. And that search function we just learned, it's a generic one, is it? So in this case, what it plugged in is integer, okay? So this is integer. And the second case, what we did over here is we add a number of characters, okay, to our array list, V2. And over here, okay, so over here you see, like this is called casting. And we learned also before, is it? So you can also do casting, is it? And the previous, we also said generic, one of the nice things for generic is it can avoid casting. But it doesn't mean casting you never need, is it? Like in this case, you do need a casting, okay? So, and then for this case, then the search method can search character, is it? Can search, and for the character array. So you see, we just define a single search method, but you can apply it to various type, is it? And it will automatically know which type to plug in based on your type argument. So over here it shows, yeah, so generics, one of the nicest benefit for it is it does promote like the code you reuse, is it? Why we need a method? Method concept is also code reuse, is it? And the class is one of the feature for class is also it can also provide code reuse. Okay, so this is this example, a generic method we kind of review. And then what next? Let's show, yeah, let's take a look at this one. A raw type example. What does that mean? Okay, and here the key concept is that raw type is unsafe. Okay, and we will see this example, the raw type. So what this class itself is a pretty simple one, okay? Pretty simple. And the class, what it does is try to find the maximum between two objects, okay? Find the maximum one. And the first definition, I just say, oh, it's going to return a comparable, is it? A comparable is an interface. And what its parameter are two comparable type. So the two parameter comparable type. And within it is quite simple. You just call the compare to method from the compare interface, is it? To compare those two parameter. And if you take a look, and then in our main, I plug in the string, a string and an integer. And by our instinct, we know that's not right, is it? But you will see, if you take a look, you will see the program didn't complain any error. So it's fine, is it? So the compilation is fine for this Java code. It didn't complain. And this comparable, this kind of use, we call it a raw type because we didn't, generally speaking, comparable interface itself is a generic, is it? Each time if you try to use, you're supposed to plug in with some specific type, is it? And over here, we didn't specify. That's because generic is not starting when Java started. It's later. The concept, generic concept, was brought in later version of Java. Okay, so but the previous version of Java, they just have this kind of raw type. Is it? So how do we make our code like also comparable with raw type, etc.? That's also the question. And so let's take a look. If I run this program, then you will see. So if I run the program, then it reports error. It reports error, and you can try at home also. So the idea for this example shows is when we write our code with raw type, there is no compilation error, but it has a runtime error. Is it? And the runtime error for program, it's basically it's not a good choice. Is it? You don't want your product got shipped and users start to use and then it's broken. You don't want that to happen, is it? Yeah, so we should try to avoid that. And then in this case, let's see, if I comment out this, if I use the other version, okay, and I try to save it. And if you take a look, then in this case, we wrote this max method with what? It's a generic method, is it? And this method we also discussed, we have the keyword extends, is it? And this extends keyword is a bounded one, is it? So that means the T got, so whatever T class is, it got to implement this comparable interface, is it? So that's the concept. Then in this case, it makes more sense, is it? In this case, looks like. But if we take a look, if you take a look at the, if you take a look here, if you take a look in the main, when we invoke the max method, is it? You see that error reporting, is it? So it says error reporting. Because why? Because over here you have two different types, is it? So with this thing, with this kind of implementation with generic, then over here it can detect compile error. So it can find the compile error. And when it finds the compilation error, you know that the program has some problem. Is it? So that you want to ship your product. Is it? So you need to correct this problem. So over here is because you have two different types, but in your generic method itself, both parameters, even though they are generic, but they need to be the same type. Is it from either both string or both integer or both employee or both account? Is it? Otherwise, it will report error. And also, once again, here it also shows Java is a strongly typed language, programming language. So once again, so strongly typed. So now over here, it catch the compilation error and let you know at the compilation stage that the program itself has some problem and you need to correct it. So once again, show the nice thing for strongly typed programming language. Okay. Okay, so this is the second example that we discussed today. And the third example, we are going to see how do we implement like the stack class we discussed before. But this time, let's take a look. How do we implement it as a static stack class? So this time, I implement my stack class as a generic stack. As a generic stack, is it? So over here, you need to parameterize it. Parameterize this stack, okay, using the angle brackets and T or other type. And for this stack class, we also implement a clonable and comparable interface, is it? And over here, we also say, okay, for this comparable, it's for the stack. We also specify the class. Okay, so this part is fine. And then next, let's continue to take a look at our code. And the other parts, the capacity, the top index, it's similar, is it? But for our array, then this type need to change to the parameter type that you defined for your generic class, T, is it? Okay, and then for our constructor, the default constructor, and this is array, is it? And for the array, then you need to always, whenever you want to use array, you always need to do new, is it? And as we said, you cannot do new T, is it? So that's not allowed. You cannot do new T capacity. That's invalid. This is invalid, is it? So we cannot do that. Then how do we initialize T, is it? Or how do we initialize the array, is it? So here, what you can get around is you can call object. So that's fine. The object is still concrete class, is it? And you can, over here, we use cast. And then later on, you can cast it. Is it cast it to whatever the type, okay? So that's the one of the point here in this example. Regarding array, how do we initialize it with generic type? And then for the second constructor, similar. So that's the key point here. You can use new object whenever you have an array, okay? If you want to create a generic one, then you can cast it. Okay, so nothing new here. And empty function, it's pretty similar as what we already learned. And for the push function, the item you're going to plug in this time is also changed to generic type, is it? So T, okay. And similar, because over here we didn't do the bounded stack. What we here implemented, if the stack is full, we are going to double size it. We're going to double size. So then in this case, you needed to create an array again, is it? Then to do that, you can call new object, okay, with the specifies of the array of objects, then you cast it, okay. So over here it shows how do we initialize the array in this case. And the pop function is also pretty similar as what we already discussed. And the pick is similar, so nothing new here. So basically nothing changed here. And the toString also nothing new. We just keep do the append with using string builder. And for clone, okay, and for clone over here, well, what we did is a deep copy. So you can also use array itself, okay. It has a function called copy of. Then it will do element by element copy. Then we return a copy of the stack. And we also implement the compare to method for the comparable interface. You just compare with another one. But here, later on, we are also going to see there's a more comprehensive compare, is it? Over here, the compare is, we just try to use the simplest case based on stack size to do compare. Okay, we didn't do element by element stack comparison. Later on, when we learn a collection, we will see for compare there is another quite useful interface that can do multiple level of comparison. Okay, and then let's take a look at the driver part. Then in the driver part over here, what we did is we first, then you see it's just like what we learned from generic stack. So we can also, so this is our own version of generic stack, is it? So this time, if you want, you can create an integer one, is it? We create an integer one, then we call push, and we can do whatever we want. And the second one is also an integer one, so nothing new, you just call push, is it? And we can also call the compare method for the two stack comparison, okay. And what over here I also shows, let's see, also show, oh yeah, over here I have some methods, so we are going to discuss it. So first, let's take a look at this search method. This search method, then in this case, we are going to search for an integer stack. So you just plug in with an integer concrete type. And for the implementation for the search function, what over here we did is we create a copy of our deep copy of our stack, because you don't want to, each time you call search, then your stack will be empty. You don't want that happen. That's why here you create a deep copy of the stack. Then you just do search on this a clone of the stack. And here, nothing new. I remember previously in our, when we discuss the stack, we also discuss the search method. And what next part, the other two method over here is this method clean sentence. It's just a regular method, okay, deal with the string. So over here, I just try to get rid of all of the non-numeric letter. So if it is numeric letter, non-numeric, non-alpha, okay, so if the letter is letter, or if the letter character, if the letter from the string is digit, then you are going to also convert them to lowercase and to build a new string. And this new string only has lowercase, alpha, and a numeric letter. So that's what this new string will have. So that's why I call it a clean sentence, okay? And then for the next method, for this next method, I'm going to reverse the string, is it? And we are already kind of familiar, okay, with the reverse string, is it? When we learned stack. And what over here does is you have this string, then you're going to reverse it. And in this case, we can use stack. And we say one of the benefit thing for stack is it can reverse some other collection, is it? But this time, you see, we use a character stack. Is it? We create a new character stack. And then you just push whatever the letters to this stack. And then you empty out the stack. You will get a reversed version of the string S. Like the palindrome check lab, it's kind of from this concept, is that you compare the original string and then with a reversed string. Okay, then in this main program is that we have an integer stack, and I also just showed for the search method, for not to search, for that reverse. For that reverse sentence, is it that reverse, that method, it use a character stack, is it a character stack? And then we can first reverse a sentence, is it? And then we can call equal to compare, then to find out if the sentence is a palindrome. Okay, so that's regarding this example. Just to try to show how we can create a little bit of more comprehensive generic stack, a generic class. Okay, and the last part of this unit, generic unit, is another very important concept. It's called a wildcard. Okay. Let's first take a look at this one. Okay. So over here, there is another concept. We call it wild cards. Okay, wild card. If let's take a look at this method. So this is a method. It's called a print list. Okay, this method return type is void, so nothing returned, and it's a static method, so it's a class method. It doesn't need any instance to use it. And later on, let's take a look at the parameter. Okay, so the parameter name is list. And the type is from generic list. So list is kind of just like array list. Okay, some similarity between them. Okay, so later on when we learn collection, we will get to detailed discussion. But anyway, this list is some data structure. Okay, it can hold a group of items, so a collection of items. But over here, let's see, we use angle brackets, is it? And previously we learned whenever the brackets, normally you do T, is it? Or T extends and bounded. So either very generic or bounded generic, is it? But this time within the generic, it's a question mark. Okay, it's a question mark. So what this is not called generic, this is called wild cards. So this concept is called wild cards. Okay, this wild cards, so it's quite flexible. It will support whatever type of objects you can use. So over here, it has some similarity between generic. Okay, but be careful over here is this method is not generic. This method itself is not generic. Is it because we don't have any generic thing? Okay, it's just this method's parameter. It takes some unbounded type of objects. We call it wild cards. Okay, and then let's see. Okay, for us to use this parameter, this is a parameter, and over here we use for each loop. Okay, and this is quite popular. Okay, use for each loop and use the colon. And over here, you see, when we specify the type of the object, we specify the type as object. Is it? Versus if you use generic, then the type over here should be T, is it? But because this is wild card, is it? So over here, we just make it the type as object, because object is also a kind of general, is it? And here, once again, it says, is it? Java is a strongly typed programming language, is it? And because this method itself is not a generic method, it's just its parameter has some very general, broad range of type it will support. So that's why over here, when you use for each loop, then you can use a very general type, okay, object, because you don't know what the type is going to be. So anyway, so this method itself is not comprehensive. It's just loop through this collection and try to print out every single item from this list. Okay, so that's this method. And over here, we have this wild card. Okay, we have this wild card. A wild card is very general. So you can plug in later on, basically we can see any kind of concrete object. And then next, let's see over here. For this example, what I explained is if you, let's take a look on the project part. On the project part, if you take a look, you will find, it has two folder, is it? So basically over here it's two class. I also have another animal package, okay? And let me first expand that. And for this animal package, so let's take a look. I have an animal class, a pretty simple class, animal, okay? Just have some instance variable. Is it like a name of the animal, animal weight, animal height, animal speed, and the count of the animal. So this is a pretty straightforward class based on our knowledge. Then under this class, I created two subclass. So I expand animal. One is called pet class. The pet class, I have owner and the pet ID. Is it a number of pet? And then I have another called wildlife. Okay, wildlife is also subclass of animal. Okay, so what here I'm care about its habitat and its ID and the number of the wildlife. Okay, so that's this class. And over here in this example, I'm trying to use those three classes, but I package them in a different package called animal. So that's why over here, I also import them specifically. Okay, so I import animal class from animal package, and I also import a pet class from animal package, import a wildlife class from animal package. Okay, so that's what I did over here. And then for the next part of our code, here, I first create an array list. So array list of animal, okay, and I call it ARR1, okay. So the type is an array list of animal, and then I add some animal like eagle, some wildlife, okay. And here, be careful, okay, A1, be careful, A1 type is animal, is it? And the second item I add is not animal, it's wildlife. Is it? Why this is allowed? Because wildlife is a subclass of animal. Is it? So it is still animal. So that's why it's not contradictory with your array list type, because your array list type is animal. Okay. So this is still allowed. Okay, and then I call some method called add animals. Okay, so don't worry at this point. And this add animal we are going to see. And then I create another wildlife W1, is it? And then I also call that method called add animals. Then I call the print list method that we just discussed. Okay, so that's what so far this example covers. And then let's take a look at this add animal method. Okay, this add animal method, if you take a look, this is not a generic method, okay, just a regular method. But in this regular method has two parameters, a list and a W, is it? And the type of W is pretty straightforward. It's just our wildlife class. And the list, parameter, the type is a list, is it? But this time, if you take a close look, for this parameterized list, it has that question mark. And we already know question mark represents the wildcards. Okay, but after it, we have two other things. We have a keyword called super, is it? And after super is the class that we defined, wildlife, is it? So what does this mean? Okay, so this means this is called a lower bound wildcats. Okay, so what this question mark allows the type is any type of wildlife and its supertype, not its subtype. Okay, so over here we have animal class. If we draw the hierarchy, we have animal class. Then we have what? We have two we have the pet class, and we also have the wildlife. Is it? So it will allow wildlife. It will also allow animal because it's super. Okay, so any of wildlife and its super class will be allowed. Assuming you have another class, suppose we call it a wolf. Okay, then wolf is not going to be allowed. Okay, so no wolf in this case can be plugged in. Okay, so it will only apply to wildlife and animal. So that's what we call the lower bound wild cards. Because sometimes you want a certain general cases, but you want it to be limited within certain range. How do we achieve that kind of goal? Is it when you define your method? So you can use this kind of lower bounded wild cards. Okay, the concept. Okay, so that's this case, the add animal, is it? So it will only allow wild, the list, the array list type will only be allowed as wildlife or its superclass, is it? So over here, then let's come back again. So our ARR1, is it? The type we define it is what? It's animal, is it? Animal is superclass. So animal is superclass of wildlife, is it? That's why when we call the add animal, we plug in with ARR1, is it? So this is okay. That's why it's okay. Okay, and then you can plug in other wildlife type, otherwise for the second parameter. So the second parameter, but be careful, second parameter got to be wildlife. Okay, it cannot be animal. Okay, so in this case, so the first one will allow animal, is it? Or wildlife. That's the second one can only be wildlife. Okay, so here once again, prove the concept of Java's strongly typed. Okay, so follow that rule. Okay, so that's this case, the add animal. Okay, then let's take a look, the remove animal. Okay, another method here. So we also define a second method, we call it a remove method. Is it remove method? So second is it's a path parameter. And the first parameter, it's also some wild cards appears. Is it? And but this time we didn't use super, we use extends. Is it extends? And so you have a question mark and extends, then what's this called? It's called upper bounded wild cuts. Okay, so then what it means it can be animal and any of its subclass. Is it, in our case, it's pet and wildlife. Is it? So those will be okay. Okay, so any of its class, okay, then it will be okay. And assuming like here, assuming if we have animal, is it, and above it, suppose you have memo, then if you want to plug in with array list of memo, then that's not going to be allowed, okay? So that's the idea here. So in this case, this is called, the previous one we discussed is called lower bound, and this is called upper bounded wild cards, okay? So be careful, and then it use extends keywords. Okay, for this one, that makes sense. Then let's see the second part of our driver. The second part of our driver, we create an array list. Again, is it? But this time, this array list type is what? It's pat. Is it? It's pat. And then we add some pat. Is it? And pat P1, P2. Is it? To this AR2. Now I call that remove animals, is it? And this time I plug in what? AR2, is it? And this AR2 type is what? It's pat, is it? Because what? Because pat is subclass of animal, is it? So the question mark is extends, is it? Extend. So this met the rule. Met the rule. Is it? Because this is pat's upper bound is animal. Is it? So it allows any of the animal and its subclass. So pat is animal subclass. So that's why this time this is okay. Is it? So it just shows us a lot of flexibility. Okay. So that's the whole concept of a wild card. And we can run this program. You can see it runs perfectly, is it? So it works perfectly fine. So this is regarding wild card. So here, just to be careful, okay? Whenever you see our method, we use wildcard, it's just provide with you more flexibility, allow you to allow more class type of variable that you can plug it in with that method. But the method itself, be careful, it's not a generic method, okay? So just be careful, it's just a wild card, it's a different concept, okay? So basically we are done with all of the general idea about generics. And so tomorrow we are going to learn a new concept about linked list. Do you have any questions? No question. So can you all just like what you did yesterday, just type on the chat, just type your name so that I can keep track of and I can give you guys some bonus points. Yeah, just give me your name, okay? And also, I remember, is it next week or the week after next? We're going to have a third exam. And I remember I already posted the third exam information on our course website. Is it next week? Next Thursday? As I remember, is it next week or the week after? I don't remember exactly. Okay, but make sure. Oh, okay, it's next week. Okay, so also you probably you can study it in case there is any question. Just let me know. Then no more question. So then I'm going to see you all tomorrow, and I do recommend you come tomorrow because that's a brand new concept, linked list, and it's a little bit of complicated, but it's a very nice starting point for the linked way implementation of all of the data structures. It's because so far what we learned about like stack cube, we learned is to implement using array, etc. So in the real world, there is some other way to implement. It's called linked way. So that's a brand new concept. Okay, and then it's very nice. So I'm going to see you all tomorrow. Bye.